What is going on, guys? Welcome to this Python tutorial series for data science. In today's video, we're getting into three-dimensional plotting because up until now, we've always used 2 dimensions, and now we're getting into the third dimension as well. So we're going to define 3D plots, and this is the topic of today's video. So let us get into the code. So as always, we start by importing NumPy and Matplotlib, but today we're also going to add another library called MPL Toolkits. So we're going to say from MPL Toolkits import mplot3d. Now, this MPL Toolkits library belongs to the Matplotlib stack, so you should have it installed on your computer, and we're going to use this library, mplot3d, in order to make three-dimensional plots. So the first thing that we need to do is you need to define an axis where we're going to plot on. So we're going to say x equals plt.axes, and now we have to specify the projection. So we're going to say projection equals 3d as a string. And that's basically the setup that we have to do, and now we're plotting in a three-dimensional context. So what we can do now is we can say plt.show and see that we have a three-dimensional coordinate system. So as you can see, we don't have the usual Matplotlib coordinate system. We have a three-dimensional coordinate system, and we can use it in the same way. So we can scroll around here, we can zoom in, zoom out, all of that. So it's basically just an empty coordinate system that we can plot in. Now, of course, since we're dealing with 3 dimensions, now we have to specify 3 axes or 3 different variables or 3 different lists. So what we're going to do now is we're going to define an input list of z, which is just mp.linspace. Give me, I don't know, from 0 to 30. From 0 to 30, give me 100 different values. And now we're going to say x equals np.sine of z and y equals np.cosine of z. And what we're doing now is we're basically creating a three-dimensional function, and on the x-axis we always pick the sine value of z, and on the y-axis we always pick the cosine value of z, and then we get an interesting 3D plot. So what we're going to do is we're going to say x dot plot 3D, I think that was the function, and then we specify x, y, and z. So I hope I did everything right. Okay, we don't have an attribute plot 3D, so what was the function name? The function name was, oh, it was 3D, but with a capital D. So yeah, as you can see, we create a sort of spiral here. So we have the input values, and then we also have, actually the labels are a little bit messy right now. Yeah, we have the input values, we have x and y as a sine and cosine, and this is what we end up with, basically just a three-dimensional spiral. Now what we did here is we used z as an input variable and then defined 2 different functions on 2 different axes to plot a function that is basically, or to make a spiral by applying 2 functions on our inputs. And we can also go the other way around, so we can just say x and y are both inputs, and then we use a z function that uses both of them. So what we can do here is, let's just delete that, we can say def z function. So this is our actual function, and it takes x and y as a parameter, and we can just return np.sine of np.square root. I'm just looking for a crazy function. Np sine of np square root of x to the power of 2 plus y to the power of 2. So this is a function that should look kind of cool. And now we're just going to say x equals np dot linspace from -5 up until 5. And we want to have 100 different values. And the same goes for y. Now, in order to plot that right now, we need to convert it because we have to use a different function here. We cannot use plot 3D. We're going to use plot surface because we now have a surface. We don't have just a spiral or a line. So we're going to use the plot surface function. But the problem is that before we do that, we need to convert our vectors, our NumPy vectors, into matrices. So to do that, we're just going to say x and y. This time we use capital letters. So we say capital X and capital Y equals np.meshGrid, this is the function that converts our vectors into matrices, we're going to say meshGrid x and y, and then we can just say capital Z equals Z function of capital X and capital Y. And we can then just plot the surface of X, Y, and Z. So this should work. And as you can see, now we have a surface. It looks kind of cool. It might lag a little bit because it's doing a lot of calculations and I'm also recording. But basically, we have plotted this function that takes two inputs and then creates a fancy plot, basically. And of course, we can even do a little bit more of that, but I think my recordings might crash if I do that. Because this function looks kind of crazy when you get into, yeah, I think I don't have to say more words about this. That's basically the function when you look at the values from -50 up until 50. So it's a kind of crazy function, but you can plot all kinds of different functions with the plot surface method and with Matplotlib in general. So this was three-dimensional plotting with Matplotlib in Python, and I think we're kind of done with the Matplotlib tutorials because we now know how to style, how to use subplots, how to plot different types of charts and graphs. We know how to plot 2D functions, 3D functions, and I think we're kind of comfortable right now with Matplotlib, so we can build on top of that and get into the next tutorial or the next part of data science, which is pandas and data frames. So I hope you enjoyed this video and I hope you learned something. If so, hit the like button for me. Also, feel free to ask questions and give feedback in the comment section down below. And of course, if you want to see more of these free videos, subscribe to this channel to support it. So thank you very much for watching and see you in the next video. Bye.